guess what? For this course, and I
All right, so now we're getting Getting into the details of Microsoft Azure. In this video and the next couple of videos, I want to give you a really broad overview of all of the services that's offered in Azure along all of the major categories. Now, I should warn you straight up front that Microsoft Azure is huge. There are literally hundreds of services underneath the Azure umbrella. And so it's actually going to be quite difficult for you to just comprehend every offering that Microsoft Azure offers. And so do set the expectation that you're going to feel overwhelmed at first. So then just, ingest it a little bit at a time, learn one thing and then the other. Microsoft is so huge, it's very hard to imagine somebody as being an absolute expert in all of the areas of Microsoft Azure. So keep that in mind as we go through this. But this first video and the next couple of videos are going to be talking in general about an overview of Microsoft Azure's services. Now, if you're starting from this course with absolutely no understanding of Azure, you've got no background in it, you might actually want to watch my fundamentals course, the AZ900 course. That could actually give you some basics into the foundations of Azure, cloud computing, what the terms are, the various concepts. I'm not going to be able to duplicate my entire AZ900 course in this single video, of course. So that's a good place for you to start if you are really starting from absolute zero. Microsoft also has some training under their Microsoft Learn website, microsoft.com/learn. Here's an example of a 10-hour Azure Fundamentals course. It is a lot of reading, and there'll be opportunities for you to practice what you learn as well. Totally great. I highly recommend it, and they're always adding more information. There's hundreds of modules basically. So go check out Microsoft Learn as well if you are starting from scratch and need to know the basics. But in this video, I do want to talk to you about the basic Azure concepts. That way we're all starting from some baseline. Maybe you're experienced in some sections, but not as experienced in others. And so this is sort of my base setting video that before we get into the details of independent services in this course, we want to talk about the basics. Now, to me, the basics are those three core services: virtual machines, virtual networking, and storage. I look at this like a stool that has three legs. Virtual machines, virtual networking, and storage, almost every other service in Azure is built on one or more of these. So if you are using, machine learning, you're actually using a combination of virtual machines and also some sort of storage concept. And Kubernetes services are built on virtual machines and Service Fabric as well. Basically, this is the foundation of the house. This is the solid base on which a lot of other Azure services depend. And so it's important to talk about this so that we understand what we're talking about when we're using these terms. So the first term is a virtual machine. Now, you hopefully have heard this before, but what exactly is it? It is either a Windows or a Linux operating system. It is a server that you can control. You can remote desktop into it or SSH into it. It looks and acts and behaves just like a real server. But the virtual word indicates that it's not actually an entire server that you are physically controlling. It is a server that's been virtualized and like a pizza that's been cut up into slices, and you only control one piece. But you wouldn't know that because it looks and acts and behaves just like a full server. Virtual machines must be on a virtual network, and they can be arranged in certain types of availability sets or put behind load balancers. You can physically distribute your virtual machines in a way that you've designed. Since you do have full control over the virtual machine, that means you can remote into it using RDP or SSH, install software, change configurations. You're also responsible for that operating system, and so you have to keep the patches, security patches installed, and make sure you've scheduled updates and reboots and stuff like that. Virtual machines can create it very quickly. Within 3 or 4 minutes, you can have a VM running. So you can have an idea at 2 o'clock in the afternoon, and by 2:15, you'll be remote desktoped into that virtual machine starting to work on your idea. Now, like I said, virtual machine is a foundation on top of which other compute services provide services. So when you get a Kubernetes container, you're actually working with virtual machines under the hood. Kubernetes is just an abstraction. It's an orchestration layer on top. Same with virtual machine scale sets. It's basically a way for you to have a load balancer. And multiple virtual machines and auto scaling rules using all the basics of that, as well as batch and service fabric. Now, a completely different paradigm to a virtual machine is what's called an app service or a web app, right? So these are basically a platform as a service. Now, you do get your choice of Windows or Linux as well, but you're not controlling those operating systems. So you can choose the Windows OS, but you don't get a say in terms of exactly what version of Windows and when security patches are applied, etc. These are fully managed servers and you don't have remote access into them. Now, as fully managed servers, what you do have access to are the applications that you can install on them, And Microsoft gives you a few core programming languages such as the .NET languages, Java, Ruby, PHP, that you can write your code in and install them as app services. These are known as developer-friendly service. So basically it integrates into Visual Studio, one-click publish, continuous integration available. It has integrations with GitHub. You can use things like deployment slots and lots of different benefits as app services above a virtual machine. Not to mention the fact you're not managing the hardware or the operating system underneath it. Moving on to the Azure storage category, storage accounts can be quite large. You can have up to 5 petabytes. Of in a single storage, and of course you can create multiple storage accounts. Storage accounts don't cost you anything to create. They charge you based on the number of gigabytes that you're storing. So currently about 1.8 cents per gigabyte. So if you were to try to fill one up to get that 5 petabytes in terms of storage, you're going to have quite the bill every month, something like $50,000 a month if you can fill up a single storage account per month. Now, files that are stored in a storage account are actually broken up into blobs, queues, tables, and files, and I have different storage structures. Blobs is the most common, and you would use containers within blobs to store your files. It also comes with a type of replication. So at the most basic level for locally redundant storage, when you are storing your files in a storage account, Microsoft is keeping 3 copies of that file behind the scenes. So if any hardware fails or a data center fails or some type of catastrophe was to happen, Microsoft would have 2 additional copies of your files and then be able to not lose your files. It's extremely rare. I think there's 11 nines of durability for locally redundant storage and 16 nines of durability for globally redundant storage. You get your choice of storage tiers, which allows you to determine whether you want to save money on the storage fees or save money on the access costs. Depending on your usage, there might be some ways of saving money depending on the storage tier. And storage is an unmanaged thing by default. If you're creating virtual machine disks, you might want to look at the managed storage, which is another abstraction above this, and it's also charged differently. It's not charged per gigabyte, but it's better when you're dealing with virtual machines because it's optimized for randomized access. Now, file storage is not the only thing that Azure supports. There's also data storage in terms of databases. Now, you can basically broadly separate out the data storage types in terms of whether they're based on the SQL Server engine or they're not. If you're looking for databases that are based on SQL Server engine, you've got the SQL Server running on a virtual machine. That is probably the closest that you're going to get when you're migrating from your on-premises into Azure. You can migrate into an Azure SQL database. It still runs on the SQL Server. Migrating closest that you're going to get when you're migrating from your on-premises into Azure. You can migrate into an Azure SQL database. It still runs on the SQL Server engine when you're dealing with virtual machines because it's really separate supports. There's also data storage in terms of databases. Now, optimized access supports. There's also in terms of whether they're based on the SQL Server engine or they're not. It's probably the closest that runs on the SQL Server engine, sort of managed by Azure. It's designed to the non-SQL Server analytics, where you're storing multi for transaction base. It is a NoSQL database, non-relational database. You can have data stored like MongoDB or in DocumentDB and Cosmos DB. Space to store that. Moving on, we are also getting out of the core sets of services. We're talking about microservices. And so you may have heard this term Service Fabric. It is another way of managing applications that are running on a virtual machine. Functions are small pieces of code that you can write even in the browser. There's a functions editor built into the portal. Logic apps very much remind me of SQL Server integration services or a Windows workflow where you've got logical steps either in parallel or in serial that happen one after another, if-then statements, conditional loops, etc. API management is a powerful service that you can put in front of an API to throttle it and to secure it, put some rules in place, or even to modify the data as it comes and goes. And finally, we talked about containers, and containers are effectively a microservice. You can create multiple small container apps, run them in Kubernetes service, and basically becomes a microservice. Another one of the foundational technologies, of course, is networking. Now, networking is actually a fairly big topic. As you would imagine, in the cloud, there are dozens and dozens of services related to networking. So I'm going to break them down into 4 categories. So networking can be broken into connectivity, security, delivery, and monitoring. So the connectivity services in cloud computing is basically what you expect when you're thinking about networking. This is what would normally be cables and wires and hub switches on your physical network, but this is all software in the cloud. So it's called a virtual network because it's just a database entry. Microsoft already has their own physical network, and they're not plugging and unplugging cables based on your commands. Wide area network virtual WAN allows your offices to connect to each other with Azure as the middleman. ExpressRoute's a much faster way to connect your office into Azure. Costs a bit more, but it's a private network, doesn't run over the internet, and it's encrypted, and it's faster. Of course, if you don't want to get an ExpressRoute, you can use a traditional VPN. There are point-to-site and site-to-site VPNs. That way your office or your computer can connect into an Azure network securely. It's encrypted. It does run over the internet, but people shouldn't be able to spy on your traffic. We've got a section that's talking about the Azure DNS service. It's basically a way of having private or public domain names managed by the name servers within Azure. Peering is a way of connecting multiple virtual networks together so that you can have your services in one region talking to the services in another. By default, these things are fairly cut off from each other for security purposes. Deny by default is a big thing. But if you can set up a peering relationship, then you can allow traffic to go through. And Azure Bastion, relatively new, it's been around for a couple of years, but it allows you to remote desktop into a server without having to open the RDP ports or run the RDP software. It is basically a more secure version of RDP. Now, the second category of networking is called delivery. And basically, this is how traffic is routed. Security. Rephrase. The second category of networking is called security. And these are, we're living in the cloud world, and hackers are a thing that you have to basically deal with. And so Microsoft provides many different services that allow you to shape your traffic and restrict unauthorized and unauthenticated people from getting to it. So network security groups is a fairly simplistic access control list style. Azure Private Link allows you to take what used to be public endpoints and turn them into private endpoints and then connect to them. Denial of service protection. Basic is free by default. You can upgrade to a standard version which protects your applications as an intelligent protection against hackers or denial of service attacks effectively. The firewall, of course, most applications are going to need a firewall, and you're going to want to look into the Azure Firewall Service. Another type of firewall is WAF, the Web Application Firewall. This is built into the Application Gateway product. There was also a version for Azure Front Door, which we'll talk about in a second. But it's basically a firewall that can recognize some of the top 10 or top 20 most common types of attacks, cross-site scripting, and SQL injection and all those things. And finally, virtual network endpoints. So the third category of networking is called delivery. This to me is like a traffic shaping or a load balancing type of networking service. The CDN, content delivery network service, is in here. Azure Front Door is like a global load balancer. Traffic Manager is a cool little hack of the DNS that allows you to distribute traffic around the world. Application Gateway and load balancers are two different types of load balancers. One being an application level 7 load balancer. The other being transport level 4 load balancer. And then the last category of networking is called monitoring. And so, without this being your own network, you don't have an easy way of watching traffic travel over your network. And so Azure has different services that allows you to debug problems, investigate things. Like, let's say you're not able to connect into your Azure network. You need to understand what part of your security is blocking it. So those are the monitoring services. And this has been a long video so far, and I appreciate you still being here. But there are literally hundreds of other services, everything from machine learning and cognitive services, the media services for transcriptions of videos, Internet of Things, the event hubs and queues, the service bus, chatbots, hundreds of services in Azure. So don't expect to be able to come in here and I just listed you 50 services. You're not going to learn them all in a day. So just absorb what you can, take it slow. You know, use your curiosity to drive you deeper into things that are more interesting to you. But yeah, there's a lot, and this is a review. I do encourage you to continue on with the course. I'm going to get into a lot of this course covers a lot of the topics that were in this video, so don't feel like I'm just sort of skimming through the topics very lightly. This is just the overview, and there's sections of the course for many of the topics that we've talked about in this video.